Glaciers are slightly moving rivers of ice, and so we have the kind of the same idea we talked about beforehand regarding erosion, transportation, deposition, but we think about these suckers have a whole lot of power. And so although they're slightly moving, because they're such massive structures, they're definitely going to do their damage. All glaciers, as I've mentioned before, are either advancing or retreating. What causes them to advance is just simply the increasing weight of continuous snowfall up there in the zone of accumulation is going to then cause the weight to then go either outward or forward based on what type of glacier it is. And so the simple idea is if I had just a big pile of pizza dough and I put my weight on top of that pizza dough, what would happen? That pizza dough would spread outward in all different directions. A nice simple way to understand and relate to this whole idea of increasing weight on the top is going to cause the flow to go outward from that area. And so it originates as snow on land, and then the stress of combined with the weight and gravity then causes the flow to go either forward or outward. So we have very much a characteristic as far as at the bottom, a plastic-like substance. Glaciers move downhill because the ice is not strong enough to support its own weight, especially against the pull of gravity. And so we have this idea of increasing snowfall is going to cause this sucker to move outward, or in this case downhill, and so gravity combined with that weight does that. Further, where the base or the bottom of the glacier actually touches the underlying surface or bedrock, there's a bit of viscosity, or to maybe use a term you might know better, there's a bit of lubrication. And so imagine our good friend KY jelly. And so what that does is that offers a little bit of this fluid substance that allows the ice then to move slowly, but move further outward and forward. Glacier is the most powerful erosive force and also known as nature's bulldozer. And key to understanding is a process called abrasion. So the erosive process involves a couple characteristics, but the main one we're going to focus in on is abrasion. Simple idea here is moving ice. What it does is it plucks away debris and then carries it. So we have this initial plucking away of these large, sharp, angular rocks, and we'll showcase this in a following animation. Over time, those debris, those bits and pieces that have been plucked away, are moved to the front of the glacier. It very much acts like a conveyor belt, which moves from the rear to the front. So the origins of a glacier to the frontal edge of the glacial boundary. And so we see this idea of this debris being carried to the front, and it's carried to the front typically down there in that lower level, what I talked about, where we have a little bit of viscosity and lubrication. Further, the idea here is the debris brought to the glacial's front. Key here is you also have kind of a smoothing of the surface. So when we understand the U-shaped characteristic of a glacial valley, key to understanding is the role of abrasion as far as smoothing, instead of a V-shape like we talked about with rivers, smoothing it because of the weight, but also because of the other bits and pieces rubbing across the surface and smoothing it, so essentially polishing it. So imagine if you just rub rocks together for a long, long time, eventually they're going to be quite smooth because of the abrasion that's occurring. Further, when a glacier melts and is eroded, we have what we call unsorted sediments that are deposited at the mouth or the front of a glacier. We're going to call this a moraine. There's different types of moraines, but the idea here is we have deposition, so transportation and then eventually deposition. What do I mean by an unsorted? The idea is pretty much everything is just dropped in place. There is no layering. There is no specific patterns as far as finding a certain characteristic like silt, then clay, then gravel, and certain layers. No. It's just completely unsorted, just dropped in place. A key characteristic of what we'll find at the end or the glacial boundary where a glacier stops is this deposition. In the place where a glacier forms, the snow and ice accumulates in an area without any melting processes, and that's why it accumulates. If there was melting processes, it wouldn't accumulate, and we call this upper level the zone of accumulation. Then we have this other area that's separated, and separated by what we call the equilibrium line. So this red line would symbolize the equilibrium line. Simple idea here is the amount of accumulation, so snowfall and ice formation, is equal to the amount of melting. And so in other words, the losses of ice and snow are balanced out by the amount of accumulation. Down in the bottom at the zone of ablation, here we see increased evaporation and melting exceed the amount of snowfall. And so here we're going to find more of the melting. And so we see these different characteristics in these two different zones. In this image here from Mount Rainier, we can see at the top, we can see the zone of accumulation, and at the bottom we can see more of the zone of ablation. So one of the things you note first off is this simply the color. So here we've got freshly packed snow at the top, whereas at the bottom you're going to get a little bit more melting, but you're also going to get sediments and bits and pieces of rock that's actually been plucked away and because of abrasion been moved down to the front and deposited down here towards the bottom of this slope. Here we see a place in Wyoming where we can clearly see that equilibrium line. We can see where we have the zone of accumulation to the right or up the slope, and then of course the zone of ablation down at the bottom. Here we can see evidence of plucking. This massive large chunk of boulder to our right has been plucked away a long time ago. But one thing to know is when glaciers melt, essentially everything they carry, they just drop in place. So in this case, this big, huge angular rock to our right was brought by a previous glacier that was previously here in this area, but then subsequently dropped here. And so this is good evidence of plucking, what I've talked about beforehand. Two key types of glaciers. We're going to talk about mountain glaciers next, but here in Indiana we're overwhelmingly affected by continental glaciers and their various historical eras that have come through this area.